Page 36. Corrosion and protection. Corrosion of metal is the deterioration that occurs when metal reacts with the environment. Electrochemical corrosion occurs because of the movement of electrons from a metal to the environment. An electrochemical reaction will occur in the following situations. 1. Both types of electrodes are present, including the anode and the cathode. The anode is an electrode that attracts negative charge. Cathode is an electrode that attracts a positive charge. 2. There is current flow in a complete closed circuit from cathode to anode through a conductive solution, an electrolyte. The anode electrode will be corroded because the anode in the metal will melt down to be a positive ion in electrolyte and move to the cathode. In general, when left unprotected in the air, most metals will corrode, the same as iron. For example, copper and aluminum, which will be oxidized and become rust. But this rust is different from iron rust since its oxide will be packed as a thin film on the metal surface to protect themselves from oxidization. But iron oxide is porous, so it cannot protect from oxygen and vapors in the air, which react with iron. Iron will continue to corrode when left in the air for a long time. Page 37. Protection of equipment from corrosion. Alloy used. Each alloy can be resistant to different environments. Before being applied to an actual situation, studies must be done to ensure that it is known which alloys can resist to each different environment. 2. Metal purification. Pure metal is more resistant to corrosion than a mixed or impure metal element. However, pure metal is not as strong as an alloy, so this can be used in specific cases only. 3. In cases such as with chloride or hydrochloric acid, a corrosion-resistant metal may not be available. Materials such as rubber, graphite, or plastic can be used as a substitute. Ceramics are useful for protection against high temperatures, but its uses are limited due to its fragility. Page 38. 4. Environmental change. Changing the environment in which the metal is stored can reduce corrosion. This can be accomplished by the following. Changing corrosion inhibitors, such as reducing the amount of chloride in the water. Separation of oxygen or oxidizing substances, such as removing the air out of the water before filling in the radiator to prevent boiler corrosion. 5. Coating metal surfaces with an organic compound. An organic compound in this case means a coat of paint, but painting cannot prevent corrosion completely because all kinds of paint are porous. So a corrosive substance can penetrate inside any metal. 6. Coating metal surfaces with an inorganic compound. This can prevent the inside of metal from corrosive substances by coating with other metals such as chromium or zinc. Aluminum, zinc alloy coating. Steel substrate. Aluminum, zinc alloy coating. Multi-coating material. Page 39. 7. Cathodic Protection. This prevention is used for anode only. This can be done by adding an electron to the metal that needs to be protected. The metal used for the anode must have a lower voltage than the protected metal. Generally, magnesium is used to cover steel objects such as steel pipes buried in the soil. Magnesium will act as an anode and the steel pipe will act as a cathode. Such corrosion will occur on the magnesium while the steel pipe, which is a cathode, will not corrode. 8. Using an already corroded product. Corroded material can be used as a protective substance to protect other materials. For example, a lead container such as sulfuric acid H2SO4 will have a lead sulfite PbSO4 coating the surface. This protects the lead and does not lead to further corrosion.